So,
So,
uh, where shall we start? Uh, yeah, okay, I can give a small update on the log uploader. I was working
oh,
on that last
like
month,
that.
and I haven't had much time to finalize it. It was kind of working. I wanted to push it to a branch so you could test it, Rob, but there's a I introduced a new bug where the menu doesn't really work anymore. So, like you have to press double and it refreshes the screen with the menu again, and then you have to press again. So it's kind of annoying, and I'm trying to figure out what I changed because I
Mm,
did change the menu a little bit. So because the logs, um, like it's also some kind of menu, so you can scroll down to see the logs, and then you can select the log and
mhm.
then upload them. So I had to change the menu a little bit, and now it's I introduced a bug, and I
Okay,
haven't been able to fix it yet. Um, I'll
but you can push it,
I can
so
still
we
push
can
it.
see
Yeah, that is true.
we can fix the bug maybe. That makes it easy for you.
Yeah, well,
You never know.
I don't know. I tried to look for it and I couldn't figure out why it was working before because I kind of didn't change anything on that logic. So it's kind of interesting. I asked the AI if they could find something, and they came up with all weird solutions that were not the
Mm,
reason at all. So
okay,
AI is useless as often. Um, but yeah, I can at least push it, and you can test the
that's
upload.
it.
You just have to press a few times, and it's a bit clunky, but yeah, I think
But
it
then it
works.
works.
I did
Okay,
upload one log to the Safecast API, so I am happy with that.
okay, good. Mm, good to hear that.
Yeah.
Did you do the? Oh, Louis is waiting. I can see that. Good.
No.
Did when did you upload it? Because I'd like to know because we did a lot of changes 2 days ago on the API. A
Hmm.
lot of cleanup. There was a lot of junk there and a lot
I
of
think
depreciated.
it was last month, I think.
Okay, so that should be
Yeah.
fine then. Yeah.
Yeah, I also
Okay, good.
rejected
Okay.
it, and I was like, it was just a test, and it was an old log. So
Okay.
um,
So I will
yeah,
check. Yeah, please push it. So more pushing is better.
yeah, I still have to connect my Codeberg to the Codeberg repository. So
Yeah.
let's see how that works.
Okay. Another challenge.
Yep.
Hi, Louis.
Good morning.
Good
Good
morning.
morning.
Well, good whatever. How you doing,
Good
Good
Louis?
evening.
whatever. Good whatever.
Afternoon here. Yeah.
No, yeah. No, doing good. Yeah.
Well, there's
And
three
I
of us on the
saw,
same time zone.
mhm, yeah. And I saw Michael just showing up quickly, but I think he disappeared again.
Yeah,
I don't know what happened.
I'm still
And
here.
for, oh, good, 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 good. Didn't hear you. So Louis, what's the exciting updates you have for the synth? Because I like to hear about what you're doing.
Well, right now, not much. I mean, I've got the micro is just, I mean, just displaying something, and if I send it a pulse, I put a little clicker on the board, right? A little LED and a little
Oh, okay.
speaker, right? Just, I mean, why not? Um, the first part I'm testing is this, like the super cheap amplifier using a 74 HCU, right? The unbuffered inverter.
Hmm.
And that, I mean, I can read it down to about 17 millivolts a pulse, which I guess it's okay, but it's really noisy. So um, we'll just keep that for later. I just wanted to, it was the simplest to look at, the simplest to troubleshoot, and the simplest to eliminate right away.
Hmm.
Next, I'm going to be working on the actual op amps, the high speed op amps. and just try and play around with right. There's going to be a trade-off between gain and noise. There's also the fact that these photomultipliers, these silicon photomultipliers, are extremely capacitive, right? So that just eats your bandwidth like crazy. There is a trick in the art of electronics for a transimpedance amplifier to have a little voltage follower to support some of that or to counteract some of that resistance. I'm not there yet. So right now I'm just looking at a voltage amplifier. For the transimpedance amplifier, I have to use a different configuration, right? Because now I use a negative bias and pulling basically current, so that it's a negative going current, which using an inverting amplifier gives you a positive going pulse.
Yep.
And that's and I'm not even close to looking at a negative bias supply right now. I'm just going to use my bench supply that I have here and all that. But soldering, let me tell you, soldering, first of all, I made a goof. I had 0805 footprints everywhere, and I started stuffing it with 1206s. So I'm looking at this, it's like, how come the pads are so small, right? I used the 1206 on the actual on the part that's going to be that holds on the little board that holds the photomultiplier itself. So I just kept on, just kept on going. It actually soldered all right, believe it or not, using that. I was supposed to send you that a link to that.
Yeah.
Sorry, I'll do that.
No, you did send. You sent the link already.
Oh, I did. Oh, okay.
The heater. Yeah.
Yeah, it works great. I've had good luck with this. Like I mean, with vendors from China, they come and go, but this vendor seems to be reasonably solid. So that's why I went with them. Anyway, so the next step is voltage amplifier, and just basically playing with the resistor values, capacitance values to give me a pulse that looks reasonable.
Did you check Mihai his schematics?
No, I didn't.
I would suggest you, because you can stand on his shoulders. I mean, he's done a lot of work on it already. That saves you a lot of troubleshooting.
Yeah, I realize that. And there's a lot of different, but they're all using transimpedance amplifiers, which is basically a current to voltage amplifier, right? And or trans resistance. And the SIPMs that I'm using, the ones from onsemi, have a voltage out. It's basically capacitor coupled voltage out. So I want to try that first.
Okay.
So, but yes, absolutely. There's quite a few out there, both on Hackaday as well as just generic, GitHub publish, as well as stuff, scientific papers presented by people at CERN who really ought to know how to capture pulses.
To do that, yes, I think so. That's the main job
now,
there.
Now some of those are a little bit extreme, right?
Yes.
They're refrigerating their electronics to 5 above absolute zero. So that's a little bit out of my league.
Okay. And Steve, how's your Zen doing? Doing okay? You received it? No? No? Well,
you're muted.
I muted.
I haven't received it yet. It seems to be stuck in U.S. Customs, according to the track.
I thought you already had it. Okay. So let's wait for it then. I thought you already got it, because I got an information that it was on the way. I mean, I thought by now you should have gotten it.
Yeah.
Okay.
Actually, let me just look at it. Okay, actually it says as of today it's out for delivery.
Oh, okay. So
Okay,
maybe tomorrow.
today or tomorrow.
Okay, good, good, good. And Jelle got the parts too, eh? I saw that it was
Yeah, they're
delivered
still at my
to your
mother's
mother.
place. So
To your mother's place.
I forgot that last time I
Okay,
was there.
good. Okay, good.
Yeah,
It's good.
happens.
And Michael, how are you doing? We didn't hear you for a while.
Oh, just very busy.
Mhm.
Um, with we finally replaced all the windows in the house. They were from 1950, single pane windows, and
Whoa.
now we've got a bunch of patching, and I've got to finish the kitchen project and painting, and yeah. So
But
35. The house we've been in the house 35 years. It's finally going to be finished, and within the next half a year or so.
oh, that's good. Good to hear
Yeah.
that.
So that's where most of my time
Good.
has been going.
Absolutely. Yes. I mean, that's a lot of work. I can
Yeah.
imagine that. You're doing it all by yourself, or
I
you have
have
other people
people,
helping?
I have some people in trade, but the people that I hire in trade, the price, it's insane what you're paying now. The first price I got for installing 9 windows was the labor alone, $30,000. I don't know how that equates to you guys.
Woo!
That's basically and each window took about an hour and a half to 2 hours to install. So it's $3,000 a window roughly. Or six,
Wow.
yeah, $3,000 a window. It was so you don't even pay doctors that much.
No. Or
So,
lawyers even.
or lawyers. Yeah.
So you cannot do
I'm
it yourself?
encouraging my grandson to go into the trades.
Yeah, absolutely. Absolutely.
Yeah.
But anyway, other than that, still have my monitoring project to monitor my current oil heater,
Mm.
so I can exactly replace that with what I need for either geothermal or heat pump replacement. So that's been the end goal as soon as the house was basically wrapped and insulated. Um, so. That's that project. I've got to push that out to GitHub because it might be something other people would be interested in.
Yes. And I think even if you make a small hardware module, you can even sell it to people. People are
Yeah,
very interested to get it.
I've got it down to a module about this big. You know, you've seen the little modules that I put together
Yes.
with the feathers.
Hmm.
Yeah, that's
Yeah.
basically what it is with a current sensor attached to the oil burner.
Hmm.
Monitors when the burner turns on and when the fan turns on.
Yeah. And if you make a nice housing around it, then it's, I mean, you can sell it. I mean, or
Yeah, yeah,
let somebody else sell it for you. Or what
yeah.
your son maybe, even maybe your son can take it up and get his own business going.
There you go. Yeah, he's busy. He's just switched jobs, so he. But you're
Ah,
right. I've already done some 3D housings for those projects. So yeah, that's a definitely a doable thing.
that's nice to hear. And for me, I'm still building sense for Safecast, and probably not sure yet. In September, we're going and do a workshop in Fukushima again, the end of
Okay,
September.
nice.
So that's good. The high school and building some sense and other things. So it will be good for Safecast. And for me, otherwise, I'm doing other things like reforesting, setting up big projects. But it's a lot of work. I mean, never done that. Setting up a company and organizing things around that and getting people involved, building a team.
Exciting.
Exciting to learn.
Yeah.
Talking with lawyers, talking with financing people, and it's a whole different world. But
Yeah.
it's good.
Take lots of
And
notes.
no, I have a lot of AI that doing that.
Oh,
That makes it much easier. I feel like I have a crew, a crew, and one part does this, another part does this, but keep the documents, and another one at the end of the day give me what I've been working on and all the time spent, and automatically behind, and we just keep working and writing. So it works quite well. I have daily reports at 11 o'clock. My report is finished. So what I've been doing, and I can track it. But the nice thing is the way I set it up. It's all stored in AnyType, and AnyType is basically a big database, and that I can pick it up from all my devices, and I can search in it. And if I want to find something I've been working on a few months ago, I just type one word in it, and it picks it up. That works really nice. I was surprised how that works. Do we have other things to talk about?
Don't think so.
Not
Okay.
really. I'm just
No?
carrying on with my build, my debugging. So
If I have a
Louis,
little
did
bit
you-
more time, yeah, go ahead. Go
Louis,
ahead,
did
Steve.
did you see that answer to your question about the scale on the spectra?
yes, absolutely. No, I was thinking of the fact that sorry, I don't know if it's reversed or not, but you've got a downward slope, and just from reading, if you have a spike here for let's whatever isotope, that there's going to be a little ledge coming down, and then a little dip, right, little cliff, and then you get to the spike. And I'm just wondering if all that Compton scattering is what's causing the downward slope.
Well, it really only matters for, something with a relatively low count rate versus
Okay.
whatever else is going on in the spectra. And there's a signal to noise ratio for that. So if the big peak isn't there, you're not going to get the downscattered Compton. So, it's just a matter of how the ratios shake out.
Okay,
But if you count longer, you can solve the problem.
right. So yeah, but you're actually raising a really good point. Is do we even want to try to for a first pass try to do isotope identification, because that sounds like a really messy problem.
It is. And for Safecast, spectroscopy is not for the casual user.
Right.
A GM tube is.
Right.
Um,
Okay.
so, um,
Yes.
but on the other hand, you can do it if your statistics is good and you're not looking at a spectra that could be similar to something else. Because if
Right.
even with high resolution, um, you get isotopes with very small branching ratios that don't have high count rates, throughout the spectra. There's a lot of ambiguity you can encounter. And
Right.
my spectra I'm showing is the gold standard. It's hyperpure germanium. Anything else is less resolution.
Right. Well, I think it comes back to the use case. If we do strictly, like clicks, right, just events, whether it's beta or gamma or whatever, then we're also compatible with the previous database entries, which was just exposure rates, right? We just change the factor from clicks to microsieverts per hour.
Yeah, right. Because you move into a solid state detector, so your efficiency is going to go way up.
Yep.
So that's good.
Mhm.
But to then do isotope ID, then you get into a whole new world.
Right. Um,
Because
but
basically,
yeah,
Louis, basically you wanted to have it as just as a click measurement. That's the first idea. I
yes,
mean, to make it cheap, much cheaper than the GM tube.
yes,
I think
yeah,
that's a great idea about it.
yeah. Well, on that topic, would it still be okay? So should I be using a plastic scintillator or stay with the inorganic? And I'm just wondering if this.
If you just want clicks, then plastic simulator is cheap and you can make big ones easily. Where
Right.
the spectrographic crystals are sort of by definition very small. And the only ones that can grow big that I'm aware of are the germanium ones, and all the other technologies, they tend to be only available technologically in small volumes.
Right,
But
right.
if you want a small, compact device, you know, then that answers the mail.
I see.
If you want to do highly accurate isotope identification, then the small detectors don't answer the mail as well as the larger ones.
Right. Okay. Uh, okay. Well, I was just gonna I'll just work on the electronics as a first pass, then we'll worry about the exact
Yeah.
scintillator.
Yeah, I
Uh,
mean, if you want to do isotope identification, then you really don't want to open that up to the general public of users. You'd want to have some subset because they're going to false identify. I mean, that's
yeah.
normal,
Right.
and for people who are not trained to, in spectroscopy, they'll
Right.
believe it, and then you got a problem to take it back.
Yes. Okay. Well, yeah. Your point about whatever the isotope was in that picture of the screenshot
Right.
of that. So
Right.
the fact that you recognize that this is a very short-lived isotope made it sound like
Yeah, well, no, I mean it had an energy that was close to the
yeah,
samarium line, and
right,
that's typical. And the lower the resolution, more that problem becomes.
right. Okay.
And I mean, I can speak from personal experience. Back in um, uh, Obama's second inauguration, I was working with the security forces, and I was at a portal monitor where the magnetometers are for people entering as spectators, and a gross count detector picked up somebody, as is typical. It eventually turned out to be a medical patient, which is typical. And I made the mistake of taking the handheld sodium iodide spectrometer to go check this person out, and it said it was plutonium-239.
Oh, that would get people
So
excited.
I knew that was correct because the fellow was saying he was a guy, maybe 25, 30 years old, and just coming in to see the inauguration. So I didn't bring the germanium detector because that version of the Ortec detectors is about this big, and it's heavy, and I had to weigh myself through the crowd. So I went back and got the germanium detector, and it was iodine 131. And
Yes, that makes
that's an
sense.
example where some of the iodine lines get close to the plutonium lines. And since the guy must have had a recent treatment, and I'm guessing maybe he had a therapy treatment because he
Mhm.
was hot,
Yeah.
it overwhelmed the algorithm. And things like that are normal and they happen. And that's
Right.
why you need a spectroscopist on the other end of it. First, not to panic. And
Yes.
second is to, anytime you get a hit like that, you have to resolve it, and you have to
Yes.
resolve it scientifically and have an
Right.
explanation for it. So, you know, that's the kind of stuff that'll happen. And if someone decides they want a mobile device and they take it with them and they're driving somewhere, they
Mhm.
could be passing another car with a medical patient sitting in it, which is normal,
Mhm.
and they'll get an answer,
Oh, mhm.
whether
I
it's right
see.
or wrong, they're going to get an answer.
No, I see. Okay. Right. Okay. So that that kind of narrows down the scope of my work so that I'm not trying to, deal with everything all at once.
Mhm.
So that's good to know. Thank
And
you.
Yeah. I
and
mean, I
and how
mean,
does yeah, go ahead.
I
Yeah,
mean,
go ahead,
spectra
Steve.
are always complex, no matter what the source are. If you look at a natural background spectra, it looks, a lot like one of those spectra I showed you, just a huge number of lines because you have this whole mixture of, uranium decay chain daughters, and they all have complex decay chains and, lots of lines. So, um, whether it's something of concern or something innocuous, they're always going to have complex spectra. When you look at it at the resolution of the germanium detectors, it's a lot of lines and big ones, uh, high yield gamma lines and low yield gamma lines that they're complicated.
Mhm.
That's
Do you
nature.
know how? Yeah. Do you know
Yeah, go
how
ahead.
the RAD code,
That
sorry,
was my
the
question.
radio code solves this issue because they give the impression that they can detect quite well. But do you have a radio code, Steve?
No, I'm not familiar.
No,
What is
okay.
that?
Hang on, I've got mine here.
Yeah, Louis has one. It's a very small device made by some Russians in
Um,
It's
it's very popular. It's not expensive, and it's supposed to be according to what I've heard, quite accurate. I think they are in Cyprus. They're selling radio code. Yeah, I think that's.
it's a
You
it's a
Google it.
spectrometer.
Yeah, a
Yeah.
very small one.
Well, I mean, small, by definition, it has a small detector in it, so it's going to be very
Yeah.
low efficiency and low efficiency in the higher end of the spectrum. Um, and yeah, I mean, you can put an algorithm on it and identify things, but it all depends on count rate,
Sure.
um, and how, dwell time.
Hmm.
Well, let me just say generically, not knowing that detector, there's a whole fleet of wearable spectrometer type uh, devices. You know, after 9/11, when law enforcement all wanted these sort of wearable devices, um, the early ones were just for dose rate. And later on, they started to, add spectroscopy. The software got more, basically took the same detector and they put better software on it. Yeah. And, that's a consumer grade one. I mean, the ones that the professionals use, different packaging, different features, different reliability. But they all can identify. Yeah, they do work, but no one ever makes a decision on one of those devices. If something ever comes up and it says it's nuclide X, law enforcement sends it to a spectroscopy a
And then it's
spectroscopist. Either at the state level or they send it to the feds. So no one ever makes a decision on that, and that's the issue,
that's a good.
that you can't believe it until you know it's right. You know, and a device like that, if you were somewhere in the vicinity of a cesium source, would probably do fine, um, so long as you didn't overwhelm it with dose rate. Because once you get to a device like that or any spectroscopist, if you get too much dead time, then you're going to get weird stuff out of the algorithm. So, and again, the professional devices that they come with little diagnostic in the display, like a little bar lines that are going back and forth. As you approach it, you get to the sweet spot. If you're too far away, you're not getting enough counts. If you're too close, you're going to get dead time. So you always want to be right in that sweet spot of count rate and dead time, to get a good spectrum. So yeah, I'm sure that will work. But again, you got a little tiny detector in it, and it's going to have efficiency issues. But yeah, you know, Like I said, when it comes to spectroscopy, the famous word, it depends. It
Sure.
depends on a lot of factors, whether the data quality is going to be good or bad.
Yeah, Rob,
Okay.
do you know
Yeah.
what detector they're using in the radio code?
No,
There are
no, I'm
two
not familiar with
versions.
the device. Yeah.
There are two versions of it. There's a high quality version and a low quality version. I think. You have
Yeah.
the 301, I think it's called.
I have I think the 102.
Yeah, good. There's the 100 series. They have 100 series. Oh my God.
The other thing with spectral devices, you routinely have to do some, quality control on them before you use them. You want to put a source on them, you know. Um, and anytime, I mean, the professionals that use them, if they do get something that they want to get the second opinion on by a spectroscopist, you always then take a background somewhere else and also put a source
Compare.
on it. And typically we use like um, thorium sand, like a welding rod, or something that's not regulated, or a gas mantle or that sort of thing. And so they send three spectra to the spectroscopist: the background, the known source, and the target.
Sample. Yeah.
So, you know, uh, and then, you can do a background subtracted spectrum and then analyze the peaks. So, again, you won't have all those features, in a consumer type spectrum.
Anyway, this is the 110. So
Yeah.
it's not
Okay.
their latest and greatest that claims they can, do 70,000 counts per minute or whatever. The specs are a little bit exuberant.
Mm. They
Yeah.
are cesium iodide. They have them. And there's the other 103 is the CA, GAGG. I
Yeah.
don't know what this stands for.
Yeah,
Gadolinium.
cadmium zinc telluride,
Ah,
CZT. Yeah. Yeah. I mean, those are, they're not as good as germanium, but they're high resolution. I think you get like 2 or 3% resolution with those. Don't hold me to those numbers, but they are high resolution crystals, but they're small. And that's the age-old problem. People have been working with CZT for years and years and years, trying to grow big crystals, and they've never really succeeded at it. So they only get small ones. And yeah, those get good resolution, but at low efficiency.
Okay.
Yeah.
All right. Thank you.
yeah.
That's really good background information.
Oh, it's foreground radiation,
Yeah.
not background.
Yeah, no, but okay, yes. Yeah, it's I kind of get lost reading the Knoll book. It's just like this, it's drinking from a fire hose. And so
Okay.
having the practical side of it is certainly helping me.
Yeah. Yes, spectroscopy is not for the faint of heart.
Yeah, I see that.
No, but it's very good to know that it's not so it's much more complex than people say that this is this, but it's way complex
Yeah.
than
Yeah,
people.
and someone who's selling a consumer grade spectrometer isn't going to tell the consumer all these little subtleties.
No,
Oh,
that's
no.
well.
Because
Well, the fact is, these people keep the software proprietary. So
Yes.
Yeah.
That's also the reason to be skeptical.
well, yes. So either they're exaggerating the quality of the software, and they don't want people to see what it really is, or they're really onto something and they want to keep it their secret sauce. But either way,
Well, Well,
So-
I mean, that's probably true too for the professional instrument manufacturers like Ortec
Same.
and Thermo. They all have their algorithm. They don't publish.
Yep.
Um,
Okay, well, thank you.
Yeah,
right.
I think we're
thank
out
you
of
so
time.
much. Good. Yeah, I
Yep.
think we're kind of out of time.
We have a minute left, but
Okay, good.
Okay.
Minute to say bye-bye.
yes.
And the cat is doing fine.
Oh, good. That's
Great,
important.
great.
The new
He eats
cat, you
like-
mean? The
He eats
new
like he
cat
hasn't
we have.
eaten in a whole week, but it's like we
He
respect. Yeah.
He comes from a shelter, so
Yeah.
probably hungry.
Yes, exactly. Yeah, well, we don't want, yeah, we want him to grow up, not out.
Oh, so we all want to go out. Okay, bye-bye.
All right, take care.
Yeah.
Have a good week.
Have a good
You
week.
too. You
Bye
too.
bye.
Bye-bye.